Between 1968 and 1972, America launched 9 human missions to the Moon, 6 of which successfully touched down, allowing 12 men to walk on the lunar surface. The next chapter of lunar exploration, Artemis, aims to create a long-term human presence on and around the Moon, while also preparing for more complex human missions to Mars. In short, everything required for Mars must first be accomplished near the Moon. So what will an Artemis mission look like? Everything is designed and tested with the most important element in mind, the astronauts. This is their deep space, human-rated spacecraft, Orion, built in 3 parts. The crew module, where up to 4 astronauts will live and work. The service module, providing life support, its own engine and fuel, and a launch abort system with engines to pull the crew module to safety during a launch emergency. To launch the crew and heavy payloads, NASA is building the Space Launch System, comprising a cargo hold, an exploration upper stage, a massive core stage, and 2 extended solid rocket boosters. Altogether, this is the world's most powerful rocket, exceeding the legendary Saturn V of the Apollo era in numerous ways. Sitting on the launch pad, the entire rocket, fully fueled, weighs just over 6 million pounds, 5.2 million of which is just the fuel. Once ignited, there is no stopping what comes next. All 4 RS-25 engines and the 2 solid rocket boosters come to life, thundering the crew upwards. 2 minutes after ignition, the solid rocket boosters are spent and released. 8 minutes after launch, the core stage is depleted and separated. The upper stage fires briefly, placing Orion into a parking orbit around the Earth. Here, the crew reconfigures the spacecraft and performs system checks for deep space travel. With a go from mission control, the crew reignites the exploration upper stage engines to leave Earth entirely. The exact timing of this maneuver is critical to reach a speed that can escape Earth's gravitational pull, but also put Orion on a course that will intersect the Moon days later. Once this burn is complete, the SLS upper stage is jettisoned, and the crew aboard Orion coasts for several days toward the Moon. Approaching the Moon, we can see the fundamental differences between Artemis and Apollo. Instead of requiring Orion to be an expendable command module or carry a constrained lander, Artemis missions will pre-stage everything needed. For lunar missions, commercial and international partners will pre-position everything. This includes rovers, science experiments, and human-rated systems on the surface, as well as a dedicated lunar station in orbit called Gateway. Here at the station, a robust lunar lander can be pre-staged and a strong communications relay established. Designed with open standards, Gateway can expand as missions and partnerships develop, allowing multiple simultaneous human missions on the Moon and enabling science to continue even between missions. Gateway can also adjust its orbit for access to any part of the Moon, an impossible feat for the Apollo missions. But the key is placing Gateway in a unique halo orbit to perfect maneuvers for Mars missions. With growing commercial and international opportunities, Gateway is the ideal hub between Earth and what lies beyond. Returning to the crew as they approach Gateway, Orion must match the station's elliptical orbit to dock. Once on board, pre-selected crew members transfer to the lunar lander, while those assigned to Gateway remain on station. The lunar lander system is built for 3 steps: descending from Gateway's halo orbit to a low lunar orbit, descending from low lunar orbit to the surface, and after the mission, launching from the Moon and ascending back to Gateway. Once back aboard Orion spacecraft and undocked from Gateway, the crew fires their engine once to break from the halo orbit and again to slingshot around the Moon, setting a multi-day trajectory back to Earth. Nearing the journey's end, the service module is released, and the crew module orients heat shield first, entering Earth's atmosphere at 25,000 miles per hour, air friction slows Orion considerably, subjecting it to 5,000-degree temperatures. At 300 miles per hour, a series of specially tested parachutes deploy, decelerating Orion to just 20 miles per hour for splashdown. With each successful mission, Artemis sends in the next wave of men and women to explore our moon, proving that humanity is ready to go beyond.